Ah, the railgun, one of the coolest weapons mankind has ever built.
Seems pretty simple conceptually, like probably some high school students could make. This current builds field and this field looks like that.
I think it's time to load this thing. Get everybody in stuff together. Okay, 3, 2, 1, let's jam.
Absolutely before you are here.
Oh!
Massive current and tiny contact with big faulty current. We're fighting air tanks, throwing off the rails.
Whoa!
So basically, this project is impossible, and we should give up immediately. But I failed the last 2 tests, and I need 100 on this project to get an A in this class.
And so we continued. As we searched the internet to make ourselves feel better, we discovered the coil gun.
Okay, so now it's on to plan B, a coil gun. We run a current through a coil of wire. It produces a magnetic field. And let's just say it goes this way. Chuck a magnet through the coil, and the coil will accelerate the magnet through. So stick a magnet in, and whoosh! As soon as this magnet hits the other half of the coil, it actually gets pulled back because the players are the wrong way around. If we just stuck a magnet in here with the current running through, it would just oscillate back and forth. So with a coil gun, what we want to do is turn off the current as soon as the magnet reaches the halfway point. So now that we have our new plan for world domination, the coil gun is going to be different. So the core concept behind the coil gun is something called magnetic susceptibility and the magnetic dipole force. So first of all, a dipole moment is basically just a measure of a permanent magnet string. And notice that before this, all the magnets that we've been dealing with have been wire loops or like just some chains of wires. But in this case, when we have permanent magnets, we want to use dipoles. They're kind of just a more general way of quantifying magnetic strength. Magnetic dipoles actually have a potential energy associated with them, which is negative of the dot product of M and the magnetic field strength. And so now if we ever want to go from the potential energy to force, all we have to do is just take a derivative. So in this case, the negative derivative of potential energy is going to be equal to our force. But now, of course, how do we actually figure out this M? B is easy enough to figure out. Like, as we know, for solenoid, B is just something like this, where N is the number density. So we just got to figure out the dipole moment now. And now here's where a useful concept called magnetic susceptibility comes in. Namely, we're going to be using iron magnets, so we want to figure out how magnetizable iron is in a sense. And if we want to actually calculate the magnetic dipole moment, then that's equal to this constant, chi sub v, called our volume magnetic susceptibility, times the volume, times the strength of the magnetic field, divided by a constant mu naught. This gives us our magnetic dipole moment. We plug this back into our formula for the potential energy, we take the derivative of that, and we're good to go. We have our force. So now all I gotta do is I just gotta crunch some numbers. This can't be that hard.
So yeah, as you can see, I did the number crunching, and
It's not so bad. Here we got our formula for the potential energy in general. And using this graph right here, we were able to estimate our magnetic field. Here we calculated our differential magnetic moment, differential because it varies from place to place along the projectile since each point elongates and turns into different amounts of field. And we integrate that in order to find potential energy, which we then take the derivative of with respect to x in order to find a force. And now we can integrate f dx from 0 to halfway along the projectile. Again, halfway is because we want to stop it at the center so it doesn't get into the pullback force. And then finally, we come out to the final value of right here, this thing. And so now that we have done all the calculations, we can just plug in some numbers into the calculator. And if we use that formula, then we find
that our theoretical upper bound for velocity, of course, assuming no friction, no inefficiency, perfect magnetic field conversion into the energy, absolute conservation of energy, no dissipation whatsoever, assuming the magnetic field is something that is absolutely not, and a lot of other assumptions later, we find that it is 173 meters per second.
Okay, so for the actual setup of our coil gun, here is a little diagram. This is the copper coil. So we built this around a PVC pipe because it's pretty durable. And inside this PVC pipe, we have a boa straw through which our magnet will actually travel. So at the end of the coil, we have a photosensor. And this photosensor shoots a beam through a hole that we punch in the boa straw. And when our magnet travels far enough through the coil to where the tip blocks off this hole, it'll trip the photosensor and it will turn off the current in this coil. And so this is actually our full coil gun. We decided to go with 2 stages because it looked cooler. And these here are the materials for all the circuitry.
What we have here is a diagram of the circuit we actually used for the coil gun. You have 2 power supplies, V1 and V2, which one is big, one is strong, one's small, and used more like a control. We have 2 new objects here, transistors, P1, P2, and a diode that we haven't really covered in class, but all you really need to know about the diode is it only allows current to go in one way, and it's kind of like a safety measure. And transistors kind of act like a switch based on how high or low the current is on one of the sides. Basically, what we want to achieve here is we want to get a large amount of voltage through this coil to power the actual, to launch the magnet. We can only do that if this transistor here, which is like a switch, is closed and has access to the ground. So, what this button does here is it charges this capacitor. When it discharges, it gives it a little bit of like a higher voltage than this side. So when it gets higher than the gate voltage, this closes like a switch and we can travel down to ground and we can get it, the voltage to go through and it's powered. Next we have the photosensor here. So as a projectile is traveling through the coil and it triggers the photosensor, it actually blocks the lights, making it so that voltage doesn't travel through this to the ground, it travels out on this side. So this side is higher than this side, which means this can travel through here like that. And because the voltage is now traveling down here to this ground instead of this one, this is now low compared to that side. That means the switch here gets open, which means this turns off.
So after building everything, here is our lab data. So we can see here, we have a pretty good linear relationship between the velocity and our voltage increase. And we have our R-squared value of 0.996. And we can see that we hit a max velocity of 9.36. And that's not bad considering how our initial target was the speed of the Nerf gun. So the theoretical velocity that we calculated earlier was 173 meters per second. With our experimental velocity of 9.36, our final efficiency comes out to 0.3%. So this might sound bad, but according to Google, the efficiency of homemade coil guns range between 0.3 and 1%. Just for funsies, we also tested the precision of our gun. And we found that we had a 0.8 degree of spread.
Y'all jokers must be crazy.
And so, after completing our construction process, this is what our final product looks like. And now, you may ask, how could this possibly be art? Since the dawn of time, man has been endlessly competitive, driving them into war. From bows and arrows, to David smacking Goliath in the face with a sling, to rifles, but the future is now. And we have created a future. The future is the coil gun. However, we do not want to have an actual war. So we often play tic-tac-toe instead.
So, tic-tac-toe featuring E&M. We use this coil gun right here and we shoot the spots. If we miss, our turn gets skipped. Let's see this.
Yeah, it's not safe.
Don't worry about. Okay, you know what? Screw it. It's fine. This is fine.
You get.
Okay. That's...
It's about to fly directly into the fan.
I'm so good! I'm so good at this game.
Alright, where do you go from here, Julian?
Okay, what's the worst score for you to hit? Probably bottom right corner.
你们这要打得很熟悉。3个对。
Yeah.
你可以往上、往下、往左、往右，
Well, she can go anywhere.
斜的也可以。
Wherever you hit is fine.
Oh, she hit the top left.
Bottom left, that's all me. And she very conveniently lined it up for me, so all I gotta do is just tilt this up.
It would be a tragedy to hit the table, huh?
It would be tragic.
I don't think it would.
3, 2, 1.
Oh,
Oh, okay.
That was just the go.
Okay, not intended, but it's good.
Well, no, you have to hit this Nezu.
Oh, you gotta hit
I
it.
mean, also you just can't hit the bottom. You
哇，
know?
你这也很准的，在下面一个你就赢了。
Oh, you gotta hit it, Julie. You gotta get the bottom, Julie.
Oh my god!
Wait, Low.
Sam is a no choker.
子弹刚才
I have like a 2-1 lead right now. That's like almost a certain lead back in 2016.
Oh no!
1.
Oh no!
Okay.
Would you?
哦 I'm so good!
Oh my god.
Surely I don't blow the 2.
I'm so good!
Okay, I gotta go on top right.
Oh no!
所以你还差一点的，在这里，
Yeah,
就往上是的。
Wait, yeah, now you're under pressure.
Yeah, oh
no
no.
choker,
Oh no.
no choker, Samuel.
No choker, no choker, huh? No choker, huh? 3, 2, 1.
No choker, Samuel.
Yeah.
You're like Jimmy Butler.
What?
You're like Jimmy Butler.
They call
Clutch.
me. I'm Giannis.
Don't worry about it. Don't worry about it.
I think it's too.
Wait, that's kind of awkward. Give me a second.
Hey, 10 seconds. Wait, where's the time limit at? Where's the time limit at?
Okay.
Julie, where's the time limit?
Oh yeah!
Get it?
I think I got it. Right. I got the observer one.
就是你赢了。
It's been like speared across. Hell yeah! Thank Miss Kumar, my family, my lab group.
How does it feel winning the first ever E&M
It's
Tic Tac Toe
great.
shit?
It's novel. I feel honored to have achieved such a feat, and I believe Sam can do better next time.
So, I was up 2-1 and I lost. At least I was up 3-1 and I lost. So, at least I'm not the 2016 Warriors, so that's all a plus. Okay, bye.
As Sam's coach and biggest hater, I've never been more ecstatic in my life.
Alright.
You guys can leave my house now.
Okay. Okay.
Turn it off.
Yeah, that's right.